Hello, you're welcome to Zishan classes. We have a problem here which concerns a cyclist going around in a circle. The radius of the path that the cyclist follows, it's r. We have to find the distance r at which this cyclist can move with the maximum velocity. Okay, pretty easy. The thing is, we should know that the only force keeping this rider on the track, and if it is moving with the maximum velocity, the force which is keeping the rider on the track, it's the friction. It's the friction. It is pulling the rider this way so that the rider does not skid out of the track. So this was the only concept involved, that the friction is the force responsible to keep the rider on the track when the rider is moving with the maximum velocity. Okay, now we are going to make an equation from the concept that we just learned. Mu r, the friction, is going to be equal to mv square by r, which is the centripetal force. M into A is the centripetal acceleration. We discussed about centripetal acceleration in the last video. The value of it is always equal to v square by r, or is also equal to omega square r. So we have put the value A is equal to v square by r in this equation here, and we're going to use this to find the distance r from the center of the path for the rider to be safely moving with maximum velocity. Okay. The reaction R is equal to mg. Also, it is given that the coefficient of friction is given by mu is equal to mu naught into 1 minus r by r. Okay, it is a variable coefficient of friction. That doesn't change anything actually. It just helps us, this equation helps us change the value here, and which we arrive at mu naught into 1 minus r by r is equal to v square divided by r. We have cancelled m from both the sides. Okay. Now mu naught into 1 minus r by r into g is equal to v square by r, which gives us v square is equal to mu naught g into r 1 minus r divided by r. Mu naught g. Okay, for the maximum velocity, the value of r can be calculated using the simple expression that the velocity v reaches its maximum value when dv divided by dr is equal to 0. This implies that d by dr of v square equal to d by dr of mu naught g into r into 1 minus r by r must be equal to 0. This gives us r into 0 minus 1 by r plus 1 minus r by r is equal to 0. I have differentiated this part with respect to r. First differentiated this part, then differentiated r, cancel out mu naught g, and you arrive here, which gives us minus r by r plus 1 minus r by r is equal to 0. This gives us 1 minus 2r by r equals to 0, which gives us 2r by r equals to 1. This implies that r equals to r divided by 2. So the distance at which the cyclist should ride with the maximum velocity is half of the distance of half of the radius of the path that the rider is following. That's it. So the concept that we used is that the friction is the responsible force. Also we used a little concept about differentiation, maxima, minima, and we created equations and we solved it. That's it. So if you want to find the maximum velocity, you simply put r is equal to r by 2 in the equation of v square that we got. We put r equals to r by 2 in that equation, we'll get the value of v. So it's not that big of an issue. So I'll see you in the next video. You have a good day. Bye.